going to have a presentation by Christian. Christian is going to present collaboration in socio-technical systems. Christian is here with us all the way from Denmark. And good morning, Christian. How are you?
Good morning. Fine. How are you?
I'm good. I'm good. How is Friday the 13th treating you so far?
Oh, good. I get to go to the conference, so it's nice. It's gray outside, but it's all good in here.
Okay.
So it's nice.
Okay. What are the 5 things we're going to learn today from your presentation? Or 3 things. Let's lower that number.
Well, we're going to learn something about how collaboration works, both in a technical sense and between teams, and how that interrelates, and how we might think about that and take it into consideration when we set up architectures and teams and stuff like that.
Okay. I also know that today is your first time experience, first time this virtual conference, right? That you are
It is.
participating.
Yes.
It's the
Yes.
best day to participate in such a conference, right?
Yeah.
Friday the 13th. So
Yeah, it is. What
I
could
would
go
like to
wrong?
congratulate you on that. This is a kind of new reality that we are going in, and I'm happy for you.
Yeah.
So, Christian, the virtual stage is all yours. Let's get going.
Thank you. And I guess only this
Uh-huh.
morning I guess I realized I'm on the Pink Floyd stage, and maybe I
Exactly,
should have, yeah,
exactly.
and maybe I should have done some kind of a play on that. But I think the closest thing you'll see in the presentation to Pink Floyd is the background of the slides, which is a blackboard. So if you really stretch your imagination, it's a blackboard which you find in schools and in classrooms. And then I think there's a few lines in somewhere on the wall around teachers leaving the kids alone in the classroom or something like that. So you really have to stretch it, but I guess that's about it for the Pink Floyd references. Anyway, my name is Christian. Hello. I work as an independent consultant. I work with various clients, a whole lot on like microservice architectures, helping them move from monolith to microservices, and that sort of spills into some of the things that we're going to talk about today, which is collaboration in the systems, but also collaboration between teams and humans, and how we make these things interact. On this slide and the last slide, you can see my Twitter handle and my website, where I have a blog, which is well, right now it's not that active, but I hope it will become active again. And the reason why it's not active is, I guess, all the writing energy I have, I spend on writing the second edition of this book. This is the first edition of my Microservices and .NET Core book. I hope it's somewhat in focus. So I'm updating that to use newer technologies, moving to .NET 5 and using MVC instead of the Nancy web framework, which I also wrote another book. Very small little thin thing. Uh, Early on, you almost can't see it when I put it in on this way, so it's so small. Anyway, it's not about these books, but I just thought it'd be fun to see them. So let's get into the meat of it for this presentation. Collaboration in socio/technical systems. And the topics that I'm going to cover somewhat is sort of there's a what and a why. There's a bit about what dependencies are organizationally and technically, and then how they relate. Then we get into some compounding factors, things that just make some of these talks around dependencies even more difficult. We get into some domain-driven design stuff, DDD. Talk about a little bit about service boundaries and team relations, and how DDD talks about these things and how that's useful, and then maybe relate that to something slightly more technical. Though it's not going to be very technical, we have no code. It's on the it's much more on the human side of things today. And lastly, there's a bit of a wrap up. where I try to gather all the things from all the slides into one slide, and then we'll see if that it gives an overview. I hope it does. So let's dig into it. So socio-technical, yeah. So what? That's maybe just a bit of a mouthful, and they seem to be opposites in some ways. But what do we mean? So we mean the sum of a technical system, the people creating it, and the people using it. So when we, as software developers, software architects, and so on, create technical systems, I guess we focus a whole lot on the technical side, which is not surprising. That's our job, and that's good. But you can view the system as something slightly larger, something that includes us as well as human beings and the relations we have and the teams we are part of. You can also include the users that we create the system for. So you have the technology, the teams creating them, the developers, and you have the end users. And they all, in some sense, form a system that interacts. So we get feedback from the users. We give each other feedback. We get feedback from the system also as developers. We want to make a change based on feedback from the end users, but it turns out that the system sort of pushes back. It's not a conscious thing from the system, of course, but maybe it's a difficult change because of decisions we made earlier. So there's an interaction, and in that sense, it's a system consisting of technology and people. I think sort of realizing that can move some of our conversations beyond the purely technical, and sometimes explain some of the issues we have during development. And we can see that these parts of the technical system. So if we look purely at the technical side of it, there will be collaboration between the parts of the system, but the people will also be collaborating. And I pinpointed here the people creating the system, because that's my focus today will be on the technical system and the people creating it, and less on the people using it. So that's obviously an important group as well, but in order to scope the presentation, it's about the interaction sort of between the people creating it and the people and the technology, right? So this kind of drawing can mean a ton of things. So I've used actually exactly this drawing, I think, in a number of different presentations to mean a number of different things, which is obviously kind of a bad thing around a drawing, but it's also a good thing for this particular context. Because part of the point that I'm trying to get at is that we have these interactions between the two sides. So each of the colored rectangles um, could be teams, and those teams have some relations which the arrows could indicate. Each of the colored rectangles could also be components in a software system, or they could be services in a microservice system, or they could be different systems integrating with each other. And again, there's relationships between them which the arrows could indicate. Or you could even say that there's actually an interaction between maybe the blue one at the top is a piece of software, and the green one below it is a team. And again, there's dependencies and interactions, and that's what we're trying to get at here. Right. So dependencies. So as I said, there's dependencies and interactions. On the technical side, these dependencies tend to be things like data flow. So the arrows could indicate that there's data flowing from the top towards the bottom of the drawing that you now have on the right side of the screen. It could be call graphs. So the yellow one in the top right-hand corner could be calling into the orange one below it, which calls into the red one below that. And then you have call graphs. And again, calls here could be like method calls if you're talking just modules within one software system, or it could be like HTTP calls if we're talking services, or it could be messages over a queue or bus or something like that. all of these represent like technical dependencies, that there's an interaction between the different pieces here. We also have organizational dependencies. So if the boxes represent teams, there are also dependencies, and dependencies on that level can be things like deliverables. So one team needs to deliver a new API for another team to consume. So there's a dependency in terms of work. One team have to deliver something to another team. That dependency then becomes a technical dependency once we start using the API. Another organizational dependency can be around knowledge. So one team is already using a technology that another team needs to start using. So again, we need to coordinate and we need to give each other knowledge, or it could be part of the domain that we're working with, that one team is developing a bounded context and they know all about that, and then they try to get into, okay, what's the details of this, and need to explain it, to explain at least part of that to other teams in the organization. So we get these dependencies on the organizational level as well. And one of the things to realize is that there is a isomorphism, maybe not completely strict mathematical isomorphism, but there is a tight relationship between how we have the dependencies on the team level and on the technical level. Because why are teams collaborating and creating these dependencies? Well, it's because the parts of the system, of the technical system that we're working with, also has to collaborate and has dependencies. So these tend to actually follow each other. So we might as well realize that and take that seriously, and then actually build that into our architectures as well. So if we want to do that, then I think it helps to think about the collaboration that we design, both on the technical side and on the people side, between the teams, um, through some classifications. And on the technical side, I think we can classify a lot, well, actually all of the collaboration into three pretty distinct groups. So this is a fairly strict classification in the sense that we can sort of place everything into these buckets. First of all, there's queries. So that is one part of a system asking another part of the system for something, like get me the details of user number 506. Perform this search and return the results, please. Things like that. The commands is one part of the system asking another part of the system to do something. Please register this user, and then of course some kind of representation of the user. So like do an HTTP post with a JSON body that represents the user. Please register that user. Or it could be like update the basket on a shopping cart. Put this this thing into it. This T-shirt that I maybe want to buy. And then the last one is events. That's things that happened. So that's just one part of the system, sort of informing whoever might be interested that something happened. So a user was registered. It's past tense. It already happened. It's just a fact that you're stating. Or a purchase was made, or an order was fulfilled, or I don't know, the temperature is now 20 degrees or something like that. A fuse burst. Things happen, and you can fire off events. Often we do this over queues or buses. We can also do it over like feeds in the style of RSS. But in any case, this is also a form of collaboration that we have, and these pretty much, or completely actually, encompasses all the technical collaboration that we have within our software systems. Now, on the team side, it becomes more fuzzy. We're dealing with humans, and we're wonderfully complicated. But that also means that we can probably not just put things into just three buckets like that. But I think the stage where the video broke was here, where I was going to talk about team collaboration. We just talked about categorizing technical collaboration, but we can also talk about the team collaboration and use these two dimensions. One being the amount of bandwidth, lower bandwidth, higher bandwidth, in terms of the communication and collaboration we have going between teams. We can also look at how collaborative that collaboration is. And we have different things that we can use for collaboration. So we have like documentation. One team can provide some documentation for another team. There is some bandwidth there. We can do a lot of things with documentation. We can put in nice graphs or pictures. We can have explaining text. We can have something interactive, but it's also very one way. If we have emails or instant messaging over Slack, Teams, whatever we might use at our team, um, this becomes more collaborative. There's a back and forth going on, but the bandwidth also tends to get lower in a sense. The text become short and terse, and sometimes meaning gets lost in there. I guess we've all kind of been hit by that. We can have meetings and actually meet each other, talk either virtually or face to face, and as soon as we do that, there's more bandwidth. We can actually and we can react to what each other are saying. We can ask follow-up questions and so on. So it gets more collaborative, and we get a higher bandwidth. But meetings are pretty structured, and sometimes that can hamper both collaboration and the bandwidth. Well, depending on how we organize the meeting, of course, and that's when we can sort of move into more workshop style of things, and the collaboration goes up, the bandwidth goes up. We interact more. We try to really get everybody's ideas going, and so on. So that's maybe a higher bandwidth, more collaborative way of of collaborating. But we also have things like just the casual talk around the office um, at the water cooler or the coffee machine or whatever it be, or virtual coffee like we're doing at this conference. And the bandwidth of that tends to go up. We just speak freely, but maybe it's not necessarily as collaborative, at least not necessarily around work. But then again, sometimes we sort of come up with ideas in those informal talks, and that turns out to be a good thing. We have things like pairing, so we can do that across teams as well. We can take one member of a team and a member of another team, set them together, and they can bang out some code together and pair on that. High collaboration, high bandwidth. This is not a strict way of categorizing these different types of or means of collaboration. It's not so much types; it's more means of collaborations or vehicles of collaboration. This is not strict, but I think it's very helpful to keep in the back of your mind how are teams actually collaborating. If they're only collaborating over instant messaging, then be aware of that. That can be collaborative and it can be quite great, but it's low bandwidth, and the misunderstandings are easy to run into. On the other hand, if the only way they can collaborate is through pairing, if that's the only means you use, that's very point to point, just between two team members. It's high bandwidth, it's highly collaborative, but it takes a lot of time as well. So you sort of have these different trade-offs, and it's worth keeping in mind how are these teams actually collaborating. And that's worth keeping in mind when we get into the next steps here, where we're taking some learnings from domain-driven design and looking at the team relationships we get from domain-driven design. And two of them are the upstream-downstream relationship and the mutually dependent relationship. So the upstream-downstream means that team up in my drawing delivers something that team down uses. So team up is upstream and team down is downstream. They can also deliver stuff to each other, and that's where they are mutually dependent. Again, there's something to keep in mind. How are teams actually set up? Are they upstream, downstream? Are they mutually dependent? And then the third one that I didn't include in the slide is that they aren't actually dependent on each other. They don't deliver stuff to each other. But yeah, that can obviously happen. Less interesting in this context. Now, DDD also talks about service relationships. So there's a assumption here that we're talking about a service-oriented or microservice landscape, and I think a lot of systems are. So let's go with that assumption. We have a range of different types of relationships that we talk about in DDD. I focused on 4 here: the shared kernel, partnership, customer supplier, and published language, because I think they actually cover a lot of what we need to think about when we relate um, to the team collaboration as well, and we get back to the queries, commands, events later as well, and relate it all up together. A shared kernel is a relationship between two services where they actually share code. So that could be they have a contract in a shared package, like it could be a jar file or a NuGet package, a npm package, whatever it is. But you have a code artifact that has some shared code between them that defines probably the contract between the services. How is data exchanged? That's quite a um, close relationship because there's even code shared. You can also have a partnership relationship, and that well, I mean, that sounds like the team collaboration part, that we actually have teams in partnership, but it's a service relationship oftentimes in DDD, so it's on the technical side, but that really just shows that these things are very closely related. In this sense, it's around a situation where the consuming service has an influence on the service that provides something to the other one. So if we think about the upstream downstream, then downstream has an influence and can sort of define how the calls should look, and the other one implements that. But there's also influence the other way around and saying, no, we want to deliver this. So that's a back and forth, but not exactly shared code. Then we have the customer supplier. And again, it's actually very much about how the teams collaborate. But if we have two different services, we sort of look at one being downstream, and that's the customer, and we have one being upstream, and that's the supplier. And well, the supplier gets to decide. It's ultimately the supplier's decision, but the customer can go somewhere else. They can vote with their feet, or they can at least have requests and be listened to some extent. Then there's the published language, which is very much that the upstream it just decides and says, okay, this is how it is, and this is the documentation, this is how it looks, and then other services can integrate to that. So they publish the language that they want. The upstream, they publish the language that they want to communicate in. Now, we can sort of look at this on a scale from more collaboration to less collaboration. So shared kernel, where we actually share code, that demands that there really is some collaboration going on. Whereas a published language, well, doesn't need that much collaboration. The upstream just implements its stuff, publishes how that's done, documents it, and then the other part can use the documentation and go on their way. Also means that when we have you can also look at this on a scale of coupling. We have tighter coupling at the top, shared code, obviously pretty tight coupling, and the published language is loose coupling. We don't have to do stuff at the same time. We document how things work. Now, that doesn't mean that you can't design an API that puts more coupling into your system than you might want and then publish the language for that. Of course you can. But generally speaking, there is kind of a scale here moving from tighter coupling to looser coupling. Oftentimes we think as looser coupling as just better than tighter coupling. That's not always the case. There's also the cohesion side, and you could argue that you at least can get higher cohesion on the going towards the top. and maybe the cohesion is lower towards the bottom, again, depending on how you design things. So it's not just a clear-cut thing that you want to be at one end. The bandwidth that we had on the last slide, we at least need higher bandwidth on the top things here. If you share code in the shared kernel between two teams, or they need high bandwidth collaboration. I don't think it's difficult to get by with only low bandwidth communication. On the other hand, towards the bottom, towards the published language, don't need as much bandwidth. These are different teams. It's the upstream defines how things are, and they publish that, document it well, and that's it. There's some bandwidth there, but you don't need the high fidelity, close collaboration types of collaboration going on. Right. So if we relate that back to the team relationships, and again, this is not a strict thing, but the way I like to think about it is that the more towards the top of the left-hand side things you are, the more mutually dependent the teams are in a sense. So if they share a kernel, even though the data flow may be one way, so if you look at from the technical side, they don't look mutually dependent. Then if they share a kernel, they have a code artifact that they share, I think that makes them pretty mutually dependent. If they have a partnership where there's a negotiation going on, and negotiation doesn't have to be a bad word here, it can be a collaborative form of negotiation, where the downstream influences the upstream, and they design an API by working together. Then they are more mutually dependent than if we're at the bottom where it's a published language, or if we're in the customer supplier where the customer can have wishes and make requests, but it's up to the supplier whether they implement it or not. That's less dependent, and you have more of just the upstream downstream. It's more clear who's providing something and who's consuming something. So again, we see there's an interaction between how we choose to do it around technology and documentation, APIs, and how we choose to do it around teams and their collaboration and their setup. Right. So if we sort of look at these different styles of collaboration, we can we could say that each of these circles are teams, and they own different services. Some own more services than other. That depends on how they want to design things. So in general, you can have more partnerships when you're in your own team. So within the blue box, it's fine to have closer and tighter coupling between these services, because we can expect a close collaboration because it's within one team. Along the green arrows between the colored circles here, they are further apart. So we should think of them as more towards the bottom of the previous slide, more published language, more customer supplier, because they can't collaborate as closely. So there's a closeness issue here, that the top ones on this slide requires more closeness and the other ones allows more distance, and both can actually be good. Now that relates back to the commands, to the queries, commands, and events. In general, the queries and the commands also gives us more coupling because they are synchronous, and so both parties actually have to be up at the same time, and you have that kind of coupling. Whereas when events gives you less coupling, gives you more flexibility between the services, and you split them more apart. That reflects on the team side, where you can allow for more distance between the teams in terms of how they collaborate. So we are close to being out of time, so I'm going to I'm not going to go that much into these compounding factors. Some of them are things like, if we're remote, some of this collaboration becomes more difficult, or at least it becomes different. If we have different time zones, it definitely becomes more difficult, and bandwidth changes at least tends to get lower, but it's at least a different thing. We can also have distance in terms of organization. So can you actually collaborate directly with a team that's in another silo in your business, or do you have to go up all the way through the hierarchy and your managers? That creates distance too. Now, I'll skip this and then we'll get to the to this one, because this is one of the points that I want to make, and then I will wrap it up. That we had this drawing at the beginning, which could be services or it could be teams. Now, if we look at this as, I guess, both, and then you look at the purple one at the bottom, then everything depends on that one, both technically, and we could view it as collaboration as well. That tends to be a low performing team, but I'm putting that in quotes because it's not really a low performing team. The reason that it looks like a low performing team is because they can't change anything without breaking the world, because everything depends on them. They have high demands on them because other teams will always want deliverables for them because they depend on them, at least if not directly, then through other teams. So this is not a low performing team. This is a bad socio-technical architecture, and that's what we want to avoid. And this is the main point of my presentation, that we have to take this into consideration and we have to try to avoid this. And it looks like I'm that I'm out of time, so I will stop it here and just skip to the slide, so you have my contact again here. Thank you.